Good morning, my name is Wen Huihui from the Master of Business Analytics Programming. Today I will present my master's thesis titled The Relationship Between BMW Car Product Feature and Global Sales. My presentation consists of the following parts: overview, background of the study, problem statement, research objectives, methodology, results, discussion, and conclusion. This study examines the relationship between BMW product features and the global sales performance. The data set contains 1,000 BMW vehicle records covering the period from 2010 to 2024. Two main analytical methods are applied in this study: regression analysis and random forest. Python is used for data analysis and Power BI is used for data visualization. The main purpose of this study is to identify key factors that influence sales performance. The global automotive market has become increasingly competitive in recent years. As a result, car manufacturers rely more on data-driven decision-making, especially in pricing, product design, and market planning. BMW operates across multiple regions and offers a wide range of vehicle models with different engine size, fuel types, and price levels. However, sales performance varies significantly across regions and product categories. Traditional assumptions such as lower prices leading to higher sales may not fully explain actual market performance. Therefore, an impartially analysis using vehicle level data is necessary. Based on the background, this study addresses four main problems. First, the key drivers of BMW vehicles sales are not always clear across different markets. Second, sales volume is influenced by multiple factors simultaneously, rather than by a single variable. Third, traditional linear models often show weak explanatory power when applied to real-world vehicle sales data. Finally, existing analysis may fail to capture non-linear relationships between product feature and sales performance. These problems motivate the use of both statistical and machine learning approaches in this study. Based on these problems, this study had four research objectives. First, to describe overall sales patterns using descriptive statistics and data visualization. Second, to examine whether sales volume has meaningful linear relationships with key numerical variables such as price, mileage, engine size, and production year. Third, to evaluate multiple linear regression models when several factors are considered together. Finally, to identify key predictors using random forest and compare the results with traditional statistical analysis. The data used in this study includes BMW vehicle sales data from 2010 to 2024. After data cleaning, the final sample consists of 1,000 observations. The analysis is conducted in three main stages. First, descriptive and statistical analysis is used to understand basic data characteristics. Second, regression analysis is applied to test linear relationships between variables. Third, random forest is employed to capture non-linear patterns and identify important predictors. Python is used for data analysis and modeling, while Power BI is used for visualization. This slide presents the overall descriptive results. Sales volume is unevenly distributed across different fuel types. Traditional fuel vehicles account for the majority of total sales. Alternative fuel vehicles currently represent a smaller share, but show potential for growth. The results indicate that sales performance is influenced by market structure rather than by a single product feature. This slide shows the statistical analysis results. Pearson correlation analysis reveals very weak linear relationships between cell volume and numerical variables. No single variables can strongly explain cell volume on its own. Regression analysis also demonstrates a limited explanatory power. This suggests that linear statistical methods alone are insufficient to fully explain cell performance. This slide provides the machine learning results. Random forest is applied to capture non-linear relationships within the data. The model identifies price, mileage, energy size, and production year as the most important predictors of cell value. Compared with regression analysis, random forest provides additional and more informative insights. This highlights the value of machine learning methods in cell analysis. Based on the results, several important points can be discussed. First, BMW vehicle sales are influenced by multiple interacting factors. Second, weak linear relationships indicate that the limitations of traditional regression models. Third, machine learning methods are more effective in capturing complex cell patterns. Finally, both product characteristics and regional market factors should be considered together in business decision making. Conclusion. To conclude, this study demonstrates that BMW sales performance is driven by pricing, product features, and regional market conditions. Machine learning techniques complement traditional statistical analysis, particularly when linear models perform poorly. The findings support data-driven pricing strategies and product planning decisions. They also provide useful insights for regional market analysis. That concludes my presentation. Thank you for your attention. I am happy to answer any questions. Thank you.